Welcome to the Phoenix Prosperity Podcast, where wealth meets legacy. Join your host, Tim Fergestad, as we explore the journeys of Phoenix's finest to success and beyond.
Hello, this is Tim Fergestad. Thank you for joining us. Today's guest is Todd Thomas, founder and CEO of Woodchuck, an innovative technology leader helping companies turn emerging tech into real business impact. Welcome to the show, Todd.
Thanks so much for having me on.
All right. There's a few things I want to make sure we talk about today, not the least of which is how you got that name. But and the focus of Woodchuck, is it waste energy?
Yes, we do. We divert wood out of the waste streams and turn it into clean, renewable energy.
Very cool. Very cool. All right. So yeah, tell us about how you got started in that.
Actually, the genesis is with North Star Clean Energy, which is the public electrical utility for the state of Michigan. They reached out and said, we've got a unique problem. We have 3 energy facilities that can use biomass, but we don't have enough biomass. So we're forced to augment our fuel supply with fossil fuels. They wanted to get completely off fossil fuels, go 100% biomass. They said, can you come help us solve that problem? So we went out and we had some conversations and we came up with the theory that there was a massive supply of wood waste in construction. And if we could identify that wood and segregate it out of the waste streams, it could be a fantastic long-term supply for renewable bioenergy. So we developed the concept and we launched Woodchuck to be a startup to do exactly that, to try to go out and partner with construction companies and divert wood out of the waste streams. And it's going really well. Construction companies have responded very favorably. Construction companies are under more pressure from their end clients to provide sustainable options. And until Woodchuck came along, all of that wood was just going to landfills. The U.S. construction industry sent 41 million tons of wood to landfills last year. So for someone to come in and say, look, we can divert all of that wood and turn it into something positive has been really well received.
Is a lot of that, you mentioned like construction companies, is that like old stuff that they're tearing down, or is it just scraps or waste from their new work?
We are focusing more on new construction. And I would say that the biggest boom right now is AI data center construction. It's the biggest sector in construction, and well, it's one of the biggest sectors in anything around. It's just growing like crazy. And so, all the names that you're familiar with, Google, Amazon, Meta, OpenAI, XAI, they're all building data centers as fast as they can.
And they're not small.
No, they're massive. I mean, they're cities in and of themselves. And they all have a similar problem, that they're getting pushback from local communities that are leery of having a data center in their neighborhood and what that does to the power supply in their neighborhood. So it's really interesting. And, you and I talked about this just briefly before, but we're seeing a really interesting convergence of real estate development and public utilities and high-tech corporations that are having to learn to cooperate and partner in order to launch these AI data centers. And Woodchuck comes in and plays a small part in that. As you're building a new data center, we can help make the construction of that data center a little bit more sustainable by diverting the waste that is produced when you build one of these data centers. And the reality is, when you build a data center, there's way more waste than your typical commercial construction, because all of the servers arrive in 6-sided hardwood boxes stuffed with cardboard and plastic. So there's much more waste than your standard construction. So Woodchuck can come in and help divert all of that, make sure none of that material goes to the landfill, and it all gets recycled or turned into clean energy, so we can help offset some of the carbon footprint of the new data center. And the wood that we divert can actually produce renewable energy that can help offset the energy consumption of that data center. So we can play a small part in making it a little bit more sustainable.
Okay, can you expand on that a little bit? Is it creating energy at a nearby site, or is it on site, or how does that work?
It can be either way, actually. Right now, the projects that we're working on are primarily in Michigan and Indiana and Ohio. And in those areas, we take the wood and we process it into biomass and we deliver it to our partner, North Star Clean Energy, that has 3 facilities in Michigan. and they use that biomass to produce clean electricity.
Okay.
But it is absolutely possible to do it on site. And I think what we're seeing in the new development of AI data centers, there isn't grid capacity anywhere to support a new data center. So I think
so they're building their own.
Yes, exactly. The trend that we're seeing is they are building power sources on site, co-locating with power. And you're seeing a whole variety of different power sources. And a lot of them are hybrid sources where they will have some combination of renewable energy in combination with liquid natural gas or some other fossil fuel. But what a lot of data centers are trying to do now is produce their own power in excess of their needs so they can actually feed power back to the grid. So they're really becoming not just a consumer of power, but they're becoming a true partner in the utility grid and ideally feeding power back to the grid to, in the perfect world, actually reduce energy costs for the local community.
Right. Can you speak a little bit more to the utilities and all the needs that these data centers have? I don't know if a lot of our listeners know how demanding these things can be.
Yeah, well, in the U.S., we have an aging energy infrastructure. It's been around for decades, and local grids are built to power the communities and businesses that are there. A new data center requires a massive amount of additional energy, and there simply aren't existing grids that have enough excess capacity to power an AI data center. It just you don't see that anywhere, and so one of the first things you need to figure out when you're starting to build a new AI data center is where can we supply more power? Are there local power facilities that can be upgraded to increase their power, or do we need to build net new power capacity on site? And I think we're seeing more and more of that, where AI data centers, part of the construction, part of the development includes power production.
Right, which is partially why these things are so costly and take time.
Yes. Billions of dollars and years to develop and get online. Absolutely. And the biggest constraint right now really is the power capacity. Building that power capacity is, I would say, the longest pole in the tent, takes the most time. So you're beginning to see data centers that are nearing completion and they're still waiting on power. So you really need to, as you're building one of these, you really need to think about and plan for the power upfront.
Okay. It's a big deal in Arizona is water. And I remember like the cooling ability and the water demands on some of the, some of them were pretty high originally here, but I think they found other ways to try to mitigate that and cool the systems. So anyway, it's not just power. There's other utility issues as well that these things require.
Yeah, there's water as well. And data centers are definitely becoming more efficient. And the water can be closed systems, right? So they're reusing the same water. So the utility demands are much bigger on the power side than the water side. Water is a consideration, but you can have a closed loop system for your water, for your cooling. The power is a never-ending hunger for power.
Okay. Can you? I heard early on that they were looking into like these micronuclear sources as well. Are those playing out?
Early stages, but they have a ton of potential, a ton of promise. So there are micro units and mini units. Molten salt reactors are very popular micro units now. And the beauty of these units is they're much smaller. They're much safer than previous reactors. So you could have one of these micro reactors or mini reactors co-located with your data center, and it can produce enough energy to power the entire data center and often have excess to feed back to the grid. So there is a lot of popularity there. Liquid natural gas is having a moment. Liquid natural gas is a very cost-effective way of providing power to your data center. And we're seeing more and more hybrid solutions where a data center might build a solar field or a wind farm and use liquid natural gas.
Right.
So we're seeing some interesting combinations of power, but I do think we're seeing lots of, I mean, the big builders, the end owners of these are big tech companies that typically all have pretty high sustainability goals and they're pretty public about them. Right. So they are looking for ways to rely first on renewable energy to the extent that they can.
Okay. Are there any incentives or subsidies or anything like that for the sustainable energy space right now? Still some good ones. I mean, there used to be, I know.
That's a big discussion right now. Certainly, the landscape has changed in that regard. Solar and wind have gotten lots of federal funding support for decades, and that is not as readily available as it used to be. But lots of other energy areas are okay with that. Hydrogen people for years have been fighting. Why can't they get more funding? Why does solar get
Right.
all the funding? So I think hydrogen folks are happy to now get to compete on level ground with solar. Um, Nuclear is really making a charge right now. I mean, you brought up the micro reactors, and that's
Right.
great. The mini and micro reactors we're talking about right now are all fission-based reactions, kind of
Hmm.
similar to the nuclear that we've been using for a long time. But the really exciting development, I think, on nuclear is fusion. Um, Nuclear fusion is considerably safer, produces an abundant amount of energy if you can get it to work. The problem with fusion is it takes a massive amount of energy to ignite a fusion reaction. If you can get to that stage, it could be the silver bullet that solves our energy needs.
Okay.
And there are a bunch of startups working on fusion. There's one in particular that seems really promising called Helion. They just signed a big deal with Microsoft to power a new data center they're building up in Washington. And the interesting thing about Helion is it is nuclear fusion, but they don't actually ever reach nuclear ignition. They pull together the material and they pulse it with energy, and then as the material pulses with energy, they capture that energy with magnets, and so they're sucking off net positive energy without ever actually igniting the nuclear reaction. So you can imagine there's a whole nother layer of safety
Huh.
there, and if they can make this work, nuclear fusion could really make energy a non-issue. So we'll see if
Wow.
that works. Helion is hoping to have their first facility done and start providing power to Microsoft in 2028. And I hope they
Okay.
succeed because that could really change the energy
Sure.
landscape for humanity.
World. Yeah.
Yes.
Yeah. So, how about biofuels?
Biofuels are a big deal right now, and that's where Woodchuck sits in. So Woodchuck turns wood waste into bioenergy, and we provide that to all sorts of different energy providers to turn that into energy. And I think there are lots of power companies that are, when they're looking to renewables, they kind of like the trifecta of wind, solar, and biomass,
Okay.
because wind and solar are great, but they're intermittent, right? It only works during the day and it only works when the wind is blowing. But biomass can be stored and ramped up and ramped down. So when you use the three of them together, it allows you to control your energy, still take advantage of wind and solar when it's available, but be able
Right.
to produce all the energy you need, regardless of what the weather conditions are. That's exactly what our partner in Michigan, North Star Clean Energy, does. They rely
Okay.
on biomass, solar, and wind.
Okay. Okay. Um, I have some friends in the bigger data center space. Yeah, and that's where I've learned how big and expensive these projects are. But I know some people who are trying to get into it from the smaller end, and I don't understand how you possibly could. I don't know if there's micro data centers. Do you know anything about something like that? I stay in the multifamily space, so I don't, and I know light industrial and some other things that I think are pretty good right now for this part of the market cycle. But data centers seem to be some of my contemporaries are talking about trying to do some, and I don't see how it's feasible at that size or price range, in like $100 million, whereas these things normally are billion-dollar projects.
Yeah, there definitely are efficiencies the larger and larger you get. And I'd say the trend is to go bigger. Um, I would say most of the data centers that are being developed right now are a gigawatt or bigger, a gigawatt and a half. So they're massive, massive data centers. I mean, these are $8, $10 billion developments that take 2 to 4 years to build. And at
Right.
the end of the day, they produce, a gigawatt. Um, there's a lot of tech leaders right now that are starting to talk about the fact that these are too small, and
Oh,
that
jeez.
the timeline for gigawatt data centers is 4 to 5 years.
Oh
And
boy.
at that point, we're going to need to find new ways to produce a lot more compute power. Um, Musk has been quoted several times recently talking about data centers in space. If you can put a data center in space, you get 24/7, 365 solar energy.
Yep.
There's no cooling required because you
Yep.
can simply radiate the heat into space. So if Musk is right, we're going to have orbital data centers in 5+ years, which then makes earthbound data centers unnecessarily expensive.
Right. Well, it's not super cheap to get things up into space, but it's cheaper than that actually. So that's a great point. Um, so in terms of scaling this stuff, I mean, you have you talk to us a little bit. Our listeners know you have a book coming out. Can you talk to us about that and how that came about and what it's about?
Yeah. So I've been in the energy space now for a couple of years, and so started writing books about energy and the energy dilemma that we're facing. And the intention of the books was to really understand in a non-political level field what are our true options. Fossil fuels, renewables, what are all the different options? Where are those things available? What are the relative costs of each of those different things? So we can have a straightforward informed discussion about the decisions we want to make and what that balance of energy should be. So my first couple of books were on that subject. This new book that's coming out actually next week will be, it's called Hyperscale.
Awesome.
And it talks very specifically about what we've been talking about today, the massive new energy demands of hyperscale data centers. And I really think that the development of these data centers is driving, the next biggest expansion in U.S. and world energy production. It just has to reach the demands of compute that we see now, and it's only accelerating. We're getting, our demands for compute are growing and growing, and the only way to continue to grow that is to grow our energy production. So that's what Hyperscale is talking about. Data centers, how do we fuel them, and what's coming?
Right. Okay. Do you know Dean Cantrell?
I do not.
Oh, I had him on the show a couple months ago. He was one of the founders with Elon at SpaceX. He's down in Tucson. Phantom Aerospace maybe is the name of it. Okay, yeah, he's the founder there. But
that must have been an interesting discussion.
Yeah. Well, we talked a little bit about cars, but yeah, it was a lot of aerospace. But yeah, he mentioned the goal of putting the data centers in space. I think that was one of the things he was focused on.
Did he give you a timeline on that?
I don't recall, but I'm always amazed at how ambitious people in that space are, because they just go and get it done. That's really right. Those big ambitious goals are how you get things done, really, right? Otherwise, if you don't set your aim high enough, you find all sorts of other things to slow you down. What's that?
Yeah, I think it's a little bit comparable to the drive for autonomous vehicles. People had really ambitious goals for autonomous vehicles, and companies thought they'd have fleets of hundreds of thousands of autonomous vehicles on the road 5 years ago, 10 years ago.
Right.
And here we are, the 2025 is wrapping up, and we really still don't have autonomous vehicles the way I think we all imagined them.
Right.
There are companies that are getting close. Waymo provides a great service right here in Phoenix, right? We have Waymos all over the place, and I love them when we use them a lot. But autonomous vehicles has been a much bigger challenge, I think, than people anticipated, and has taken much longer for us to get there. So it'll be curious what we see with this surge of AI data centers, and potentially data centers in space or data centers under the sea, which has similar advantages in terms of cooling. So it'll be curious to see how fast we do ramp up the size of these data centers and what that really looks like 5 years from now.
Right. I used to read old science fiction, right, from like the 30s and 40s and stuff, and it's funny how some of these guys were so spot on with what the internet is and how it would work and how it would change things. And some things they were very off on, right? They thought we'd have robots walking around everywhere, but cameras would have to be huge. Right? And it's kind of been the reverse. But we already have the technology, I think, for the most part, for the data centers in space. I think it's just stability, really. But I think they're figuring a lot of that stuff out, so it's exciting. Um, back to Woodchuck, Todd, if you don't mind.
Sure. Yeah.
All right. So, what are some of the misconceptions about the bioenergy space or waste energy
Well,
space?
I think when people think about bioenergy or biomass in particular, they're often thinking about forestry waste or agricultural waste. And historically, that's where it's come from. And so there are some people that don't like the concept of cutting down forests to generate energy. Um, and that's not really the way it works. Typically, bioenergy from forestry is forestry residuals. So as you're
Mhm.
harvesting timber, there are parts of the timber that you can't turn into 2x4s. So you've got waste, and that's typically the material that we're talking about that becomes biomass for energy. Agricultural waste is a great source because you need to do something with all of those corn stalks or chicken poop or whatever it is, and we can turn that into energy. Fantastic. Woodchuck is
Okay.
in a slightly different area. So we are looking really at urban wood, construction wood, manufacturing wood, and there's a massive amount of that waste. Most people don't even realize how much wood waste they have. You can think about wooden pallets. You can drive by any strip mall you want and drive around the backside, and every single business is going to have a stack of pallets behind them. Everything that comes and goes anywhere in the United States moves on pallets. And theoretically, those are multi-use. You can use them over and over again. But the reality is nobody does. They get used one time and they end up in the trash. So we have all of this clean, wonderful, usable wood that's just going to landfills. US landfills are filling up 30 to 40% wood by volume. So a huge volume of our landfills is just wood. And wood is so valuable. It's a pallet actually is more energy dense than forestry residuals because forestry residuals are from green trees that have a lot of moisture in them. So you actually have to dry it before you can turn it into energy.
Okay.
Pallets have already been dried. They're already cleaned. All you have to do is grind them up, and it's a great high energy source of power. So Woodchuck really focuses on urban wood waste, construction wood waste, pallets, and making sure that none of that
Okay.
material goes to landfills, and instead we turn it into energy.
Okay. The other side of that, I was just thinking about having a certain percentage of dry wood, like mulch within the landfill, might be good for helping it turn things over and help degrade the waste that's in the landfill, though. I don't know.
Um, Landfills, as you're building them, they really want those to be dry. And the intention isn't really that those things break down and you do something else with them later. They're becoming mountains that when they're full, they're going to be sealed and 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 become little
Oh,
mountains, if you will. But there's
okay.
not no one's going to be opening those back up and trying to
In
get down the
200
lovely
years
broken down materials. Although I
to
would say,
grow farms on. Okay.
yeah, no, that's not going to happen. There is a school of thought. People are starting to think about future landfill mining, where we go back into old landfills and start to extract, particularly the metals. Right? I'll think of all the
Hmm.
cell phones and laptops and things that are thrown away in those landfills. And now we're searching the earth for those minerals, and we have huge stockpiles of them buried in landfills. Um, Landfill mining is really dirty, and so no one's
I'm
really figured
sure.
out a cost-effective way of going in there and separating the valuable materials from all of the other stuff that's in there. But as minerals and metals become more and more needed for modern technology and energy production, there may come a time when it is cost-effective to go in and mine landfills. So
Wow.
that is possible.
Okay, interesting. One more thought on biofuels is when I think of that, I think of more like cleaner fuels for putting in engines. Uh, but also I don't remember. There were some they were using organisms to create gases and other types of production, biological fuel productions, not just taking refuse or waste. Is that a big part of the industry, or is the waste energy kind of the big player?
So organic material can be turned into energy in multiple different forms. I
Okay,
mean, the most common is to just burn it to produce steam to turn turbines
right.
to generate electricity. But yeah, biomass can be turned into bio oil. It can be used to produce hydrogen. Another byproduct can be biochar, which also has other uses, particularly in farming. But you can convert organic material into multiple different ways or multiple different forms that can be used for energy in different areas. I would say when you're talking about biomass-based biofuels that are liquefied and used for transportation, you see that more in the aeronautic world. Turn it into biojet fuels.
Okay.
And you do see some uses of that today. Not a ton. It's expensive, and it's difficult to get the right balance of energy to use on modern planes. But that is an area that's, there are startups looking at that, and they're developing that all the time. Hydrogen is an alternative that I think is maybe having a moment right now as well. Hydrogen has lots of advantages. One is you can feed all sorts of material, organic material, into a pyrolysis and generate hydrogen. And a lot of times it will actually, because you do that at such extreme heat, it can break down a lot of toxic waste. So a lot of waste that's too dirty to use other ways of producing energy. You can use it to produce hydrogen, and it'll break down that toxic waste and produce hydrogen all at the same time. So hydrogen is an interesting option as well.
Okay. What are back to Woodchuck right now then? What are some of the challenges moving forward for Woodchuck?
So I said the challenges for us are right now we're really a startup. We launched 2 years ago. We're having great growth, but as our name keeps getting out there and we're making more and more contacts, we're needing to figure out how to scale rapidly and support the demand that we're getting. But you can grow yourself out of business too. So we're kind of in that exciting growth stage where we're getting tons of opportunity, and we need to start being a little bit selective on how quickly we grow, so we grow responsibly and make sure we can support our clients. So and that it is still is that a problem? I don't know. It's not really a problem. It's great. We have more demand than we can service, but that is a problem too.
Okay. But in terms of need for the waste, can you source enough waste? Do you have enough partners to find the wood?
Yes, there's tons and tons of wood waste. And again, talking specifically about the huge surge in data center construction, as we talked about before, data center construction produces tons of waste
for the future.
I mean, the projects that are on the books for the next 2 to 4 years in terms of building data centers all across the United States and really across the world, there's going to be so much wood waste that there's ample wood waste. Sourcing wood waste is not the issue.
Okay.
The other side of the coin of, where are the offtakes for that? And are there enough bioenergy facilities to consume all of that wood? That's probably the stickier wicket.
And do they need to be relatively close to where you're sourcing?
They do. I mean, biomass is expensive to transport. It's heavy. You typically are transporting it right now by semi-loads. Although if you can aggregate enough volume, you can move it by barge or by rail, and that will give you longer distance. But certainly with all energy, the closer you are to the source, the more efficient it is and the more economic it is. And that's true of everything. Anything you've got to put in a pipeline or put in a truck and transport, that becomes one of your major costs. So as we look at energy anywhere, one of the first questions are, what are the local resources? What is here in the area where we can generate enough energy that we don't have to import energy from somewhere else? That's always a big question around any development project, and certainly AI is the same.
Okay. So balanced scaling is the goal for the next couple of years for Woodchuck.
Yes, it is.
Okay. That's exciting stuff. And how do you see that going? I'm sure there's a few different routes. I mean, could you get acquired by a bigger company who wants the technology or your infrastructure?
That's certainly possible. Say right now we've built a pretty nice client list. We've got some pretty nice major national players that are clients. And our growth strategy right now is really to go where they want us. So as our clients bring on more data centers, We will go to those data centers and support them wherever they are. So, we're not saying, look, we're going to go to California. We're saying, hey, look, Walbridge, where do you want us to go? And if they want us in Texas or they want us in Virginia, we will go and support their projects. So we'll grow opportunistically based on where the projects are. And we're excited right now. We're just starting to talk to a new potential partner that has a couple data center projects in Arizona. So we would love to have our first data center project here in Arizona, and that may come to fruition in 2026. So that's exciting.
Okay, excellent. How you're headquartered here in Arizona?
So I live here in Arizona, but actually the Woodchuck is headquartered in Grand Rapids, Michigan.
Okay,
and our projects right now are Michigan, Indiana, Ohio, but soon to be spreading out nationally.
Okay, excellent. Do you have any business or personal sort of legacy plans? Big goals that you're excited about?
Well, so my wife and I have 5 kids. Nice. And our youngest kids just graduated from college in 2025. So our world changed a lot. Everything's very different now. And now we can start thinking about next plans. So I'd say we don't have anything formalized yet, but we can now start thinking about what we want to do with the money instead of sending it all to Tucson.
Okay, U of A, eh?
Yeah.
Okay, excellent. Well, congratulations on that. That's all awesome.
Yeah, a big year for us.
Yeah, very cool. You have any grandkids yet?
Not yet. Okay. Our oldest actually also got engaged this year, so hopefully that's not too far off.
Fun. Cool.
Yeah, I'm looking forward to being a grandpa. I think that's gonna be fun. Raising kids was tough. Being a grandfather, that seems fun.
Yeah, I'm excited for it too. My kids are 18 and 16, so no pressure.
You got a little time.
Hope so. Okay, very cool. So given your success, what's sort of your desired impact in the energy space, maybe, or sustainables in general?
So I really, Woodchuck is making a positive impact. I mean, right now we're still a small startup, but we're actually diverting tens of thousands of tons of wood out of landfills and turning it into renewable energy. And in doing that, we partner with North Star Clean Energy, which uses carbon capture. So we're capturing all that carbon. So we're reducing waste, we're producing renewable energy, we're capturing the carbon. So we feel really good about those big pieces.
That alone is a big deal for sure.
It is. And so now we really want to scale to make a meaningful impact. And the beauty of it is the macro factors that make Woodchuck work, the need to reduce the waste, the need for more energy. Those macro factors exist worldwide. That's not unique to the United States. It's not unique to North America. Those are worldwide. And so we can really scale anywhere. And the bigger we scale, the more positive impact we have. So that's really where we're focused right now. Could some big company come in and make an acquisition? And certainly that's always possible. And that may be how we exit someday. But right now we're really focused on building a profitable, solid business and making an impact in terms of waste reduction, cost reduction, and capturing that carbon.
Okay. Yeah. All big good things. Strong work, Todd. Okay. So what's been the driving force behind each of your books? Has it just been things as you've learned you wanted to share and consolidate the information?
Yeah. So my very first book was called Unleashing Abundant Energy. And the first book really talks about the world's exploding demand for energy. So right now, the world produces about 26 terawatts of power. And most people think we need to double that over the next 10 to 20 years. And so how in the world are we going to double energy production? If you take all the renewables, the total capacity of all the renewables today, and throw nuclear in there as well, if we were to triple all of those, it still doesn't get us to double the energy capacity globally. So if we really want to double energy capacity in the next 10 to 20 years, we're going to have to continue to use fossil fuels. We're going to have to continue to use coal and oil and natural gas. In fact, probably in bigger quantities than we do today. And so let's recognize those, basic facts.
Okay. That's what my oil friends keep telling me.
Yeah, and it's true. They're absolutely right. Oil isn't going away anytime soon. But if we all have good information and we can look at the relative costs of all of these different energy sources and the geographic availability of these different energy sources, then we can make informed, intelligent decisions about where we want to get our energy and what is that balance of fossil fuels versus renewable fuels versus nuclear. But let's have an informed decision, so we're making decisions based on fact alone. And a big part of it is geography, right? If you're in Wyoming, there are geothermal opportunities. If you're in Iceland, there are geothermal opportunities. You should absolutely take advantage of those. Texas is interesting, right? They drill a ton of oil in Texas, but Texas also leads the U.S. in renewables. Texas is putting up tons of solar farms. So it's going to be really interesting to see how the energy landscape develops over the next 10 years. But I think we need to all be eyes wide open. There isn't a single silver bullet out there. It's really all of the above. We're going to need all of the available energy sources in order to produce the amount of energy that we need. The one caveat to that is if we can reach true nuclear fusion, that is probably the silver bullet that solves everybody's problem. But we're still a ways off from that. So even if, like Helion that we mentioned earlier, if they actually can start producing fusion energy in 2028, that would be great. But to produce that on the global scale of energy we need will still take a long time to develop. So in this, the next couple of decades, as we're in this energy transition, we're going to need all the energy sources available to us. So that's what the books talk about. Book 2 really goes more into what are ways that we can be more efficient with the energy that we produce. So maybe we don't have to double energy capacity. If we're being more efficient, maybe we can slow that growth
curve. Data centers in space, right?
Exactly. But now that's kind of changing with this massive growth in demand for AI. The demand for all this new compute and all the energy that takes, maybe that puts us that we need to more than double energy capacity. So again, it's a fluid world of compute and energy, and those two are now kind of interchangeable. AI compute is power, and power is AI compute, so they're kind of interchangeable. But it still comes back to the same fundamental question: what are our true energy options? What are the true costs? And what levers do we want to pull? What balance do we want to find to produce energy in the smartest, most effective ways?
Right. As you keep saying energy and AI, you talked about new technologies, right? And fusion. I keep coming back to the advances, the bigger societal changing advances AI can help with are things like the energy crisis, right? If they can, I have a physics background, right? We got stuck in the math, right? We didn't know how to make a grand unified theory, right? We haven't figured out how to bridge, right? Quantum mechanics, right? Thermodynamics and everything. And so I'm hoping that we get some big breakthroughs through the math, right? Through AI, cold fusion, pseudo warm fusion, whatever they're doing. I think that's one of those, I don't know if it's called the black swan, but one of those unknowns that could change that dynamic entirely.
Well, I think AI is part of the problem, but I agree with you. It's part of the solution. AI is really good at finding efficiencies and developing efficiencies. And I think that's true in energy production and in lots of other areas. The applications of AI across science and medical is unbelievable, the things that it's doing. So we're going to continue to see amazing innovations with AI and what that can do in terms of improving human life.
Right. And the medical stuff's going a long way, and just, but I think its impact on energy could be the biggest thing it does.
Yeah. And then at some point, particularly when you're talking about the medical field, you start to get into ethical questions, right? Brain computer implants are are real. They are happening. There are, at least a dozen successful brain-computer implants now, and they're amazing because you have people that have, lost motor skill. They've lost the ability to be verbal. They've lost sight, and the brain-computer implants can solve those problems for them. So they're really incredibly powerful in helping people recover their lives. At the same time, you're literally putting a computer interface into your brain. And so that creates all sort of ethical questions of, how do you monitor that? How do you gatekeep that? If you're connected permanently to a computer and you're making decisions, are you making those decisions, or are you being led by the computer? So it's amazing and it's powerful, but there's also questions on, what are the guardrails we need to put up in terms of, ethical and moral questions. Fun things to talk about.
For sure. Yeah, crazy times. So Todd, if people would like to connect with you or learn more about Woodchuck or your books, where can they go? What should they do?
So Woodchuck is woodchuck.ai, and check us out. And would love for you to come and see Woodchuck AI. I'm on LinkedIn. I'm just Todd Thomas at LinkedIn, so you can ping me there. If you're interested in the books, unleashingabundantenergy.com is a website. You can go right there, or you can just look them up on Amazon. They're all available on Amazon. So yeah, check them out. Come visit Woodchuck AI or ping me on LinkedIn.
All right. Great stuff. Thank you very much. Thank you, everybody, for listening and watching. Thank you very much, Todd Thomas, for joining me today and sharing your insights into the industry.
Thank you. It was a fun conversation.
Inspired by our guests? Visit phoenixprosperitypodcast.com/guest and join us on the show and share your success story with Tim. The spotlight awaits.